So now today we will start the module 5, that is a strain energy. So we'll discuss the basic concept of the strain energy, and then its definitions, formula we'll see one by one. So when you're talking about the strain energy, what is the meaning of that strain energy? So the basic concept of strain energy is that when we apply any load, that may be a gradual or static load onto the body may be a elastic body. So if we apply any gradual or static load, that I'm giving name P is P load, on this elastic body, so what will happen? Because of this load, the work has been done by this load onto the body, it try to strain, so its length increases and becomes strained. So you can see that suppose it was initially length L, and after applying this the load P, it becomes L1. So L1 minus L, L1 minus L is nothing but I'm giving name del, this change in length. The final length minus initial length equal to change in length del I'm giving. So what is the meaning of that strain energy? When we apply any static or gradual load onto the elastic material, so this body is strained and work is done on the body, which is stored within the body in the form of internal energy, and this work done by the load is straining the body, known as the strain energy. Simply we can say that when we apply this load onto the elastic body up to the elastic limit, this body is strained because of this load, and because of that straining it stored the internal energy, and then because of this internal energy body is strained. This term is known as strain energy. This strain energy we are using the symbol U for this strain energy. So when we apply this load, what will happen in the diagram? If we draw the diagram between the load versus elongation, so when we apply the load similarly in a linear, because up to the elastic limit we apply the load onto the elastic material, what will happen? Whatever the load we apply, same time the same elongation happen, because it moves linearly up to the elastic limit. So because of this, body strain and gain the internal energy and is stored, and that term is called the strain energy. So this particular area is called the strain energy U, and this is, it looks like the triangle. So we can give this strain energy is a 1 by 2 this elongation into load, because the area under this curve is called the strain energy. This area under this curve is called the strain energy, and the area under this curve is called strain energy, and this, it looks like a triangle because it is a triangle. So the area of this triangle is nothing but 1 by 2 into B into H. So 1 by 2 B is nothing but the elongation here to here, and H is a load. So here I am writing that same U, that is a strain energy, equal to 1 by 2 elongation into load, and that can be written as elongation, that can be written as this we can write the del. I am writing this elongation and the load is P. This can also be expressed 1 by 2. That elongation is nothing but the epsilon into L we can write, and this P we can write sigma into A. Here we can see that the P is nothing but load by area is nothing but the stress. So this load can be written as a stress into area. So this stress into area can be written, this stress, and this strain can be written as change in length, that is change in length del L. I am writing change in length divided by L, or we can write this del by L. So this epsilon into L is nothing but the del we can write. So instead of this del change in length, we can write epsilon into L into stress into area. So that also we can arrange 1 by 2 epsilon strain, that is strain into stress into area into length. We can write 1 by 2 epsilon stress area into L. So that area into L here, this we can write area into L is nothing but volume we can write. So 1 by 2 epsilon sigma into that volume we can write, or area, maybe this A into L we can write, no problem. So that epsilon also we can write, this epsilon terminology we can write, this is a sigma by E into stress into A into L. Here you can see that this stress is nothing but E into strain up to the elastic limit. This is up to the elastic limit. We can write this sigma, which is directly proportional to E up to elastic limit, and then proportionality of limit if we remove, we can use this modulus of elasticity. So we can write sigma equal to E by epsilon, or epsilon we can write sigma by E. This also we can write. So similar pattern I am writing here, sigma by E instead of this epsilon, this is strain, 1 by 2 into this sigma square by E, we can write into A into L. Now again, instead of this sigma, I am writing in terms of load and area, because area is there. So we can write this sigma as a P by A whole square by E into A into L. So that sigma we already discussed, sigma is nothing but P by A. So we can write here 1 by 2 into P square by A square E into A into L. So that area here and this area can be cancelled and written as P square by L upon twice AE. So this is the formula for this strain energy. So this is the formula of strain energy. We can write strain energy formula.